Okay, so in computers there are two special modes, kernel mode and user mode. The system of dual mode operation ensures that your program runs securely without interfering with the core functions of the computer. It is like having different levels of access to keep everything in check. So in user mode, this is when the computer is working for you, running your programs and tasks for user programs. And in kernel mode, here the computer is working for itself, specifically for the operating system. This mode handles important tasks and keeps everything executing correctly. To make sure your programs can't mess with the important stuff the computer does, there are special things to consider, okay? So firstly, your programs, namely user programs, can never take control of the computer when it's in kernel mode. So it's restricted unauthorized control. This is to prevent any accidental or intentional damage, okay? And there are some special instructions, certain powerful commands, we can say, and they can only be used in kernel mode. These instructions, like setting up memory rules, are called privileged instructions. They are like secret codes that only the operating system can use, okay? And modbit is used to keep track of which mode the computer is in. There's a special flag called the modbit. Okay, when it's 0, it means the computer is in kernel mode. Okay, when it is 1, it's in user mode. That says. And for the interrupts, if something urgent happens, like an error or special request, the computer switches to kernel mode automatically. It's like calling for help, making sure the right tasks are handled safely. So in between these modes, we keep going from there to there by interrupt hardware. And from kernel mode to user mode, we need to set user mode instruction. So we can say that for dual mode, the program works like that. User wants to process, once it's processed to be executed, okay? And to do so, we need to call a specific instructions. We say system call. So we calls system call, okay? And in this system call, with this system call, we went to, how can I say? We can divide this area to 2, like this place is where the mode bit is 1, and in that place mode bit is 0. So after system call is called, okay, we execute the system call in kernel, okay. So mode bit is 0. We are in the kernel mode. After the execution of system call, it returns to user mode by setting mode bit to 1 before switching to user mode, and then return to user mode. Okay, after that, mode bit becomes 1. So we use exception or traps in the computer system, and they are like computer signals that pop up when something goes wrong in a program. For instance, if there's a math problem that's too big, we say arithmetic overflow or underflow, or if the program tries to divide a number by zero, division by zero, or if it tries to do something it is not allowed to do, okay, executing illegal extraction or reference outside user memory space, a trap happens, okay, an exception happens. This signal can also be intentionally created by the program itself using a special instruction. When a trap occurs, it switches the system into kernel mode to handle the problem and prevent bigger issues. So we can look at that figure. Okay, it's a good example to show traps and also unauthorized memory access. So in the case of CPU wants to access to a location that is not bigger than a base register, or that is not in between the base register and limit register, okay, a trap is occurs, and it says that you are trying to access a memory space that you cannot allow to do, okay? So it says addressing error.